Hello everyone. In this part, we are going to see the swapping and file space allocation. So swapping already we have seen. Now we are going to see the file space allocation. Files files are allocated disk spaces by operating systems. Now operating systems deploy following three main ways to allocate disk space to files. So first ways, that is contiguous allocation. Second one is linked allocation. Third one is indexed allocation. So contiguous allocation, all we know that there is a continuous memory space allocation is nothing but the contiguous allocation. In this scheme, each file occupies a continuous set of blocks on the disk, continuous space of blocks on the disk. For example, if a file requires n blocks and is given a block B as the starting location, then the blocks then the blocks assigned to the file will be B, B plus 1, B plus 2, means continuous memory space allocation is going on, and that is up to B plus n minus 1. Now, this means that given the starting block address, yes, we are going to provide the starting block address and the length of that particular file in terms of blocks required. In terms of blocks, we are going to specify the length of that particular file. We can determine the block occupied by the file, and we can determine how many blocks are going to occupied by that particular file. The directory entry. Now second thing is the directory entry for a file with contiguous allocation contains, first thing is address of the starting block, and second one is the length of that particular allocated portion. These things we are going to add in the directory for that particular file. Now next is the file mail in the following figure starts from the block 19. We can see that the file that is named as main, and it is starting block address is given here in the table, that is directory uh, 19, and length is 6. So for the main file we will refer first block as 19. We can see in the figure here 19 is specified, and then hence it is contiguous allocation of memory. Then we can simply go for the 20, then 21, then 22, then 23, and up to 24, because length is 6. So 24, up to 24 we are going to refer this file. Each file occupies a contiguous address space on disk. Assigned disk address is in linear order, easy to implement. External fragmentation is a major issue with this type of allocation technique. Next, advantages of this type of access, or we can say allocation of space, is both the sequential and direct access are supported by this. Means both the sequential access also, uh, in the sequential access also we are specifying, or we are allocating the memory as a contiguous memory, and in the direct access also we can specify the allocation as the sequential allocation. For direct access, the address of the kth block of the file which starts at block B can easily be obtained as B plus key. This is extremely fast since the number of 6 are minimal because of contiguous allocation of file blocks. Disadvantages. This method suffers from both internal and external fragmentation. This makes it inefficient in terms of memory utilization. Increasing file size is difficult because it depends on the availability of contiguous memory. If the contiguous memory is not available, then we cannot increase the file size. Okay. So next point is link allocation. Now we have to allocate the memory with the help of link allocation. So how we are going to store the file with the help of linked allocation that we are going to see. Now first in this scheme each file is linked list of disk blocks. Means in terms of linked list we are going to store the blocks of a file in the memory which need not to be contiguous. Means contiguous memory allocation is not necessarily applied here. We are going to maintain linked list of the memory blocks for that file. Now the disk blocks can be scattered anywhere on the disk. Yes, because we have to provide the pointer to that link. So it is scattered all over on the disk. The directory entry contains a pointer to the starting and the ending file block. Each block contains a pointer to the next block occupied by the file. Means each block has the pointer that will be point to the next block. The file zip in following image shows how the blocks are randomly distributed. The last block 25 contains 1 including a null pointer and does not point to any other block. So we can see here in the directory there is a zip file and which has a 9 as a starting block address and end will be at 25. So we can see here that directory directly points to the ninth block and here one has provided. So it is pointing to the one block, then in the one 2 is provided. So it is going to point 1 is pointing to 16 and 16 is point to 1, then 1 is again point to 2, that is 10, and 10th block is pointing to 25th. Means from 9 we have reached up to 25th one. So that is how we have saved our or we have stored our blocks from that particular file in the form of linked list on disk. Now directory contains link or pointer to first block of a file. Each file carries a list of links to disk blocks. Directory contains links or pointer to first block of a file. No external fragmentation, efficiently used in a sequential access file, inefficient in case of direct access file. Now What are the advantages? File size does not have to be specified. You need to specify the file size. It may vary according to the linked list. Now, no external fragmentation. These are two advantages of this particular memory allocation or file space allocation. And second point is disadvantages. It does not. It does sequential access efficiently and is not for direct access. Okay, so it is useful, beneficial for sequential access. Each block contains a pointer wasting space. Means yes, we have to use space for pointers, and that is extra space we are going to use. Now, next is blocks scatter everywhere and a large number of disk 6 may be necessary. Yes, as they are scattered on disk, we have to maintain number of 6. Now, reliability. What if a pointer is lost or damaged? Yes, it is not so much reliable because pointer may get damaged or lost. Next type of space allocation of the file is index allocation. In this scheme, a special block known as index block contains the pointer to all the blocks occupied by a file. Means if there are 10 blocks in a file, then we are providing a single pointer that will point to all the 10 blocks of that particular file. That is the indexed allocation. In this scheme, a special block known as the index block we can see in the directory, that is file zip is there, and there is index block value is 19. So we can see in this diagram, if we are going to refer the block number 19, it has so many pointers in it. They are going to point several blocks from the memory or disk. So in this scheme, a special block known as index block contain pointers to all the blocks occupied by a file. Each file has its own index block. Every file has its own index block. Then the ith entry in the index block contains the disk address of the ith file block. That is the thing. And the directory entry contains the address of the index block as shown in the image. Provides solution to a problem of contiguous and linked allocation. Yes, it is the solution. No need to provide the separate link, or we can say pointer, for every block of that particular file. So this is the solution of that. And next point is an index block is created having all pointers to files. So all pointers can be saved as a index block, single index block. With the help of that single index block, we can refer all the pointers. Now, each file has its own index block which stores the address of disk space occupied by the file. Directory contains the addresses of index blocks of files. Directory contains the address of the index blocks of files that we have seen on the diagram now itself. Now, what are the advantages of this particular access method, or we can say memory allocation file for file? This supports direct access to the blocks occupied by the files and therefore provides fast access to the file blocks. It overcomes the problem of external fragmentation. Yes, no more External fragmentation is here, and it supports the direct access to the block occupied by the file. Therefore, it's fast access. Now, what are the disadvantages? The pointer overhead and indexed allocation is greater than linked allocation. Okay, the pointer overhead is greater than linked allocation. For very small files, say files that expand only to 3 blocks, the indexed allocation would keep one entire block. For the pointers, which is inefficient in terms of memory utilization. However, here if small file is there, then we are providing one single block for a index block, so it is inefficient. However, inefficient in the sense of memory utilization. However, in linked allocation, we use the space of only one pointer per block. So it is the disadvantage. Now, next directory structure we can see in the next part.